So gallium is in everything from modern technology to even energy transition. Um, it sort of would be hard to isolate one industry because they all have multiple. But the best way at the moment, I suppose, to indicate which ones are relevant is gallium and germanium are currently being restricted to the US just in the last month. It's a further escalation of the technology war between, since 2018, the US and China. So price for gallium has been going up about 50% a year every year for the last 5 years. And the key thing there as well is, Tim, like you mentioned, the smartphone, it's a very good analogy. I have mine there. There's about 12 metals in each smartphone. There's gold and the silver, and the other 10 are the ones we're talking about. Now, let's suppose the price of gallium doubles. Well, it'd be far more catastrophic for Apple to shut down production of the iPhone than to pay the price increase for gallium. So anytime the prices spike, the manufacturers just absorb the price and pass it along to the consumer. But just right across the board, gallium has multiple applications. Hafnium, for example, it's needed as it's in a super alloy in a jet engine. So hafnium has this great ability to withstand extremely high temperatures and still function. So it's in nuclear reactors, it's in jet engines, rocket space technology, so rocket engines. The space industry space exploration is becoming a fully fledged space industry. I think Boeing and Airbus both reckon that the aviation fleet will double by 2050. So there's no question of a surge in demand there. The four rare earths, dysprosium, neodymium, praseodymium, and terbium, they're all very, very chemically similar. So neodymium, for example, can carry 1,300 times its own weight independently. And they're critical in electric cars, wind turbines, and solar, the new sort of photovoltaic. So that's what's, I suppose, interesting about them as well, is they have multiple applications